Hey guys, I am sad to say this is our very last math lesson for the year. 10.7, it's a good one. I know chapter 10 hasn't been the most difficult. This one's a little challenging, but not too bad. But yeah, I thought that I would do a personal lesson on this one instead of giving you another assignment. So anyways, 10.7 is adding, subtracting, multiplying, and dividing numbers in scientific notation. And so for our first couple of examples here, you have to know that we are, for the key idea here, we are adding with the same power of 10, subtracting, adding and subtracting when you have the same powers of 10. If you have different powers of 10, then you need to rewrite the numbers so that they have the same powers of 10. So here's what that means. Looking at example 1, 1a, you see that we have 10 to the third here and also here. So this one's pretty straightforward. All you have to do is add the decimal values that you have there. So 8 and 72 hundredths with 4 and 6 tenths. And you get 13 and 32 hundredths. But the problem with that is not scientific notation. Because as you learned in the last lesson, and as you probably already knew, you have to have a number less than 10 in order for it to be in scientific notation. So I'm going to show you something kind of weird here, but it's going to make sense and hopefully come in handy later on. We need this to be not 13, but 1.3. I'm saying it the wrong way on purpose. You want the decimal point here. So in order to get it there, you can view it as, what does it need to be? I'm going to undo that for a second just to show you. I want it to look like this. So that means I would have to multiply this by 10 to the, well actually let me say that again. I would have to multiply this by 10 to the first in order to get that. Okay, so I'm rewriting this 13 and 32 hundredths as 1 and 332 thousandths times 10 to the first, because these are technically the same thing. Okay, because really all you would do is slide the decimal point over once to the right. And then don't forget to bring down the times 10 to the third. So now if you're multiplying powers with the same base, you know that you add the exponents. So really that's going to be 1 and 332 thousandths times 10 to the fourth. Okay. We will practice this step again, so if that confused you, don't worry. Alright, here is the second one where you don't have the same exponents, so it's going to be a little bit more work, but not much more. Basically what you need to do here is change one of the exponents to match the other. It doesn't matter which one, but in this case we're going to go with the second one. So again, if I have 6 and 6 tenths, I'm going to do this in another color so we can distinguish with my work that I already did up there. Okay, I'm going to go with 6 and 6 tenths times 10 to the negative third. I need that to match the negative second. So basically what I'm doing is making this be the negative second, which means I would have to change 6 and 6 tenths to 66 hundredths times 10 to the negative second, and I'm basically doing that because I am multiplying 6 and 6 tenths, let me add a step in here, times 10 to the negative first times 10 to the negative second. So basically all I'm doing is rewriting this like this. I am separating the exponents as the negative 1 and the negative 2 to make up that negative 3, because as we all know, negative 1 plus negative 2 equals negative 3. Now the reason I did that step is because now that matches. So essentially, I'm going to erase this and start over again because I know that that was confusing. Essentially what we did there was matched those exponents. So one more time, let me do that because again, I know this part is confusing. I am making this expression match the other one, the exponent. So if I want to change 6 and 6/10 times 10 to the negative third to be 10 to the negative second, what I am doing is rewriting this as 6 and 6/10 times 10 to the negative first times 10 to the negative second. Okay? Because that is the same thing. So let me just pause and remind you that when you add these two exponents, you would get that. Okay? So this is setting me up because when I actually do multiply this out, if I were to actually evaluate 6 and 6/10 times 10 to the negative first in standard form, that would be 66 hundredths. And then bring down the times 10 to the negative second, and you've got the same exponent now. Okay? If that didn't make sense, rewatch it again the second time. I think I explained it better than the first time. Okay, so then, now that I have the same exponent, I'm going to bring back down that 3 and 5/10 times 10 to the negative second. I have the same exponents now, so remember that I am subtracting, so I'm going to set this up. 3 and 5/10 minus 66 hundredths. And that's going to give me, oopsies, I didn't change that. Sorry guys, it's supposed to be a 2, not a 3. 2 and 84 hundredths, and then times 10 to the negative second. Okay, now try these two on your own, and come back and check in a couple minutes. Okay, so here I have worked them out. Obviously the first one was harder than the second one. Matching up your exponents in number 1, I chose to change the second one. I just like positives better, as we all know. And so yeah, I matched it to be 10 to the second power. And then I added the first part. So that led me to this crazy decimal here. Second one's super easy. Exponents already matched, so all you had to do was subtract the 7 and 8/10 and 4 and 5/10. Okay, example 2. On this one, we are now multiplying and dividing. Sorry, that was Mr. Snick sneaking some chips, and it was really loud. Alright, so to multiply or divide numbers written in scientific notation, you are going to divide the factors and powers of 10 separately. Okay, so much easier. These ones are way easier than adding and subtracting. So first what we're going to do is multiply the 3 and the 5. That'll give us 15, and we're just going to bring down the times 10 to the negative fifth times 10 to the negative second. So as we learned previously in this chapter, same basis, add the exponents. So this would be times 10 to the negative 7. Okay, and then this is not scientific notation. So once again, the strategy here is I want it to be 1 and 5/10 instead of 15, which means I need to move it one spot, one place value. So that's why this step right here, which is probably confusing some of you, I want to change the 15 to have one digit less than 10, then the decimal point. That's what makes it scientific. This is not scientific notation because the decimal point needs to be here. Okay, so I put it there, and that means I have to move. If I want 15 to be in scientific notation, I slide it once to the left, and that means it's 1 and 5/10 times 10 to the first, and then just bring down the times 10 to the negative 7th, and then again, we're adding our exponents. So 1 and 5/10 times 10 to the negative 6th is our final answer. With division, same concept here, except we're going to divide. So we have 1 and 5/10 divided by 6, which we'll do separately from 10 to the negative 8th over 10 to the 7th. So let's start with 6 into 1 1/2 it's going to give us 25 hundredths. So 25 hundredths times 10 to the, don't forget that when you're dividing, you're actually subtracting. So I'm just going to put a subtraction sign there. So I have negative 8 minus 7, which is going to give me negative 15. So that's for my exponent there. So 25 hundredths times 10 to the negative 15. Again, this is not scientific. I need that decimal point to be in between the 2 and the 5, which means if I am sliding it to the right, that actually means it's going to be times 10 to the negative first. I always go back and check. If I need to get from 2 and 5/10 back to 25 hundredths, that means it would have had to move to the left, which is why our exponent is negative 1. Alright, and then bring down the times 10 to the negative 15. And again, same base, so add the exponents, which would leave us with 2 and 5/10 times 10 to the negative 16. Okay, on your own, try these 4 and come back to check. Alright, so here we are. Yeah, take a look at your answers and follow my work to see if you can find any mistakes, but hopefully you got them all right anyways. Alright, last one. You could do this a couple different ways. How many times greater is the diameter of the Earth, the Sun, than the diameter of the Earth? So you could change the Earth from scientific to standard, or you could change the diameter from standard to scientific. Totally up to you. Personally, if it's me, I would change diameter of the Earth to standard. So 1 and 28 hundredths times 10 to the 4th means this would be 12,800. So how many times greater is the diameter of the Sun than the diameter of the Earth? So I'm going to take this 1,400,000 and divide it by this 12,800, and I have, let's see, 1,400 over 128. So simply divide. Could be reduced, but I'm just going to dive right into the long division because it seems like it's not going to be that bad. Make sure I did that right before I go any further. Yep. It seems like it just missed the mark, so it's probably going to be 9, but I'm going to see. Calculating. Yeah, too much. Okay. I'm running out of space. I'm gonna have to move this up. Alright. Up here. Alright, sorry, this is getting a little lost here. I need a 0. Alright, there we go. Figured it out. Okay. Huh. Second thought, it might have been easier just to deal with the scientific notation because that long division. Maybe it was because of my organization. Regardless, we got there. If you did it the other way, I can show you in just a second, but let's just look at the answer here. It's going to be 109 and 375 thousandths. So basically like 109 times greater than the diameter of the Earth. Okay, and if we did it the other way, just to kind of show you since this one was crazy, we would have changed the diameter of sun to scientific notation. So that would have been, if I need to get the decimal point from here all the way to here, I would have to move 1, 2, 3, 4, 5, 6 times. So it would be 1 and 4 tenths times 10 to the 6th. So basically, maybe this is easier, I'm not sure, we'll see. I have 1 and 4 tenths times 10 to the 6th over 1 and 28 hundredths times 10 to the 4th. You are still going to have to do that division, which is basically what we just did with bigger numbers. We already know what it's going to be. And then we're doing the 6 minus 4, so times 10 to the 2nd, which means we move it over twice. So, kind of the same amount of work, to be honest with you. Either way, it's about 109 times greater. The sun's diameter is approximately 109 times greater than the Earth. Okay. On your own, you are looking at the radius this time. So decide which method you prefer to use, and then come back to check your answer. Alright, so this one was, my final answer is here, by the way, 693,600 kilometers, and this was actually, if you are finding your answer to be way off, this one said how many more, so that was just subtraction instead of division. And that's it, guys. That's the last lesson you will have in 7th grade math. Yay, you made it. So proud of you. Miss you guys. Have a wonderful weekend.